So, hello everyone. I'm here with Akond Rahman. Akond is a good friend from Bangladesh, and he and I were colleagues while at the research group by Laurie Williams at NC State University. I have tweeted a lot because I found a picture from spring 2015 where there's you, me, Raul, and lots of people. And Akond now is it right? Akond?
Yes, Akond.
Akond. This sound is not mute. Akond. He's from Bangladesh, a beautiful country. Yeah, I saw today in the map it's almost enclosed in India.
Yeah,
but it's a beautiful country. And now he's a professor at the Auburn University in Alabama. And here, Akond, we have a master's program in applied computing, which is PPGCA. And for Brazilians, if you want to be, let me just see the comment here. If people complain that the sound is too low, no one is complaining. And we have this master's. We don't have a PhD in computer science at this university, but there are two other universities close here that they have PhD students. And I see that also that you in the US, if you want to have a PhD student, it doesn't have to have a master's, right?
That is correct.
You can accept. So sometimes we have had, let me just change the configuration here because I see that, yes, this is better. And you're going to give a talk, which is State Reconciliation Defects in Infrastructure as Code. So, Akond, let me share your slides. Oh, it's blurring a little. Yes, Marlon, I have fixed that. And now, I see we can upload the slides here. Oh, maybe I can do it with PPTX. Let me remove. It's processing your slides. And we have, yes, some people, 4 people watching right now. And this is going to be at the Fronteiras da Engenharia de Software channel, which is a podcast where I interview Brazilian researchers, mostly Brazilian researchers. I have interviewed one Portuguese researcher. Of course, he speaks Portuguese, and I saw you have been to Portugal for IaC.
Yeah.
Yes, and he was one of the co-organizers of Rui Maranhão.
Yeah.
And also, I have interviewed Laurie. So let me just change the name here for your name. And I believe I can, I have to choose the right camera here because it's using a different camera. It's this one is better so that people can see you. Thank you very much. Show your slides. Oh, yes, I believe it's better if I share the slides. Okay, now I believe it's going to work. Okay, that's it. Thank you very much. The words. Em português, the word is yours. A palavra.
Sure. Thank you, Adolfo. Thanks everybody who have attended the session. As Adolfo said, my name is Akond Rahman, and I'm currently an assistant professor at Auburn University. My research is mostly in software engineering, and my research is funded by federal organizations within the US, namely the National Science Foundation, as well as. So if you want to know a little bit more about my work and what we do, visit my website anytime you want. I believe we do a lot of cool stuff that has a lot of impact for software engineers. Speaking of our group, we do have multiple openings. So if you are planning to come to the US for higher studies, I urge you that you consider joining our group. As you can see, we have a diverse group of individuals who are doing interesting work in the field of software engineering, primarily in development and operations, DevOps, and configuration management. So today we will talk about infrastructure as code. If we consider other topics such as software testing or software requirements or software security, compared to that, these terminologies or topics, infrastructure as code is relatively new, and that is why I will first give a brief primer on what infrastructure as code is, and then talk about the technical details and how we ended up with the project that we are going to present at IaC. So imagine, as you see in this particular room, we have multiple servers and computers, and each of these servers and computers have multiple software. And each of these software have multiple configurations. So there you have many servers or computers with many software with many configurations. Now, previously, what people used to do is, even for myself, system administrators, they used to manage the configurations of these multiple software and services by their own. So either by writing some scripts like bash scripts, or manually trying to go into each software and running some commands and then changing the configuration. However, as you may guess, that it works well only for say one software or two pieces of software running on one or two servers. But if you want to scale it up, and here scaling up means if you want to do the same thing for thousands of computers or say thousands of computing instances on Azure or Google Cloud Platform or Amazon AWS, then it will not scale up. So you cannot take this manual approach and do it again and again manually for 100 times or 1,000 times. So industry practitioners came up with this idea of infrastructure as code, so that you can do the same thing automatically, writing one script, and that by executing that one script, you can do the same thing for hundreds and thousands of computing instances. And that informally is known as infrastructure as code, because you're going to write code to specify the configurations of your computing infrastructure. You're going to write it once, and then everything will happen automatically. So it has yielded a lot of benefits for many organizations. I am only reporting benefits for these two organizations, Meta and Asian Development Bank, just to showcase the diversity of these types of the users of infrastructure as code. As you can imagine, the biggest benefit is that it helps you to scale very quickly, and it reduces the provisioning time from say hours or so, days or months, to something like hours or minutes. So if you have not seen infrastructure as code before, which is okay, you will. The reason I'm presenting this slide is to showcase what infrastructure as code looks like, to give you some familiarity. So this is something that is used for Ansible. It is a very popular tool to do infrastructure as code, and the code snippet that you're seeing here is in YAML format. So it stands for yet another markup language, where you have keys and values, and you specify the values for each key, and each key corresponds to a configuration of your software. And you do it in a more programmatic fashion. And just like you execute your Java code or your Python code or your C code, you execute this particular code using the Ansible tool. So it has a lot of similarities with software source code, but there are some unique differences that we're going to talk about today. And that will help us to understand why the title talk, which is state reconciliation, is so important. So I was speaking of state reconciliation. In the case of infrastructure as code, there is this key idea called state reconciliation. It sounds very fancy, but the idea is very simple. The idea is the way these tools work this infrastructure as code tools work is that first it looks for which computing infrastructure that you want to target. Then it gets all the configurations for that infrastructure, and that if that is not satisfied, only then it applies state reconciliation to make the changes that you want. More formally, it is presented in these 3 steps: inventory assessment, which corresponds to inventory stuff like what your server is, what the configuration of that current server is. Then do a state inquiry to make sure that the configurations that are in your file is either matching or mismatching. If they are mismatching, then it applies changes, which is known as state regulation. So in this particular talk, I will be discussing the outcomes of 2 papers. One was published last year as part of a workshop we had co-located with IaC, the International Conference on Software Architecture. And the latter part, which is the majority of this particular talk, is going to be presented at FSC 2024 in Brazil. So here in this particular paper, we did a preliminary study just to get an understanding of how frequently bugs appear when people try to implement state reconciliation. So we had 2 research questions, and our goal was to quantify the frequency. So here we just wanted to understand if, so we think they are buggy, so that's our hypothesis. Now, how frequently do these bugs appear? If there are some unique characteristics of that. So we focused on 2 research questions. One is the frequency, how frequently do defects occur? And here we are calling the Ansible tool as the Ansible Infrastructure Orchestrator, which means that the tool that compiles infrastructure as code scripts and then makes the necessary changes. And then the second research question was focused on which components have what types of, what is the frequency of bugs for each component. The methodology, thank you. The methodology was pretty simple. So as Adolfo knows, many software engineering research papers rely on open source repositories. So we looked into the Ansible open source repository, did a keyword search, and then quantified the number of bugs that occur. So first we quantified holistically, and then we quantified based on each component. Next slide, please. And after that, we use the gathered data to do some open coding stuff, where we actually wanted to see what are the names of the files in which these bugs appear and what kind of component it belongs to. So our intuition was correct. So we were assuming that these bugs will be frequent, and according to our results, we see that for every 1,000 lines of code, there are around 18 bugs. So this kind of aligns with existing research on other types of software systems, where we also have quantified bugs and also identified what parts of which components of the software corresponds to what type of bugs. So we identified 12 categories, and in the interest of time, we are not going to look into the categories in detail. So if you are interested, please look at the paper. But the major takeaway from this particular paper is that number 1, just like any other software system, Ansible orchestrators or Ansible tools or other IaC tools are susceptible to bugs, and they are frequent. And in this particular case, we identified 12 components in which bugs appear. So I'm going to briefly gloss over the names. So for example, there's this component called module. So these are, so you have the way Ansible is designed, that you have a core, and then which leverages modules to accomplish certain tasks. So we see that the module component has a lot of bugs in them, or at least majority of them. Then there are some other components such as the utilities, executor, claim management, command line interface, inventory, parsing, galaxy, and so on. So, like I said, the major takeaway from this particular paper is that we now have an idea that the Ansible tool itself can be buggy, and these types of components, especially the modules, they have a lot of bugs in them. So, when we finished this study in December of 2022, and then it was eventually published at in April 2023. And when we were doing our preliminary study, we felt that just looking into the generic bugs themselves might not be enough to improve the software quality assurance for infrastructure code. And so we wanted to, like I said, we wanted to focus on this idea of state reconciliation. So instead of looking all the bugs, let's just focus ourselves on the bugs that are only related to state reconciliation. And that is what the purpose of this paper is. So first we did some very preliminary exploration to make sure that the bugs that we are studying have an impact for industry practitioners. So this particular picture that you can see is from the Ansible repository, and this is actually a severe bug where the severity is 9.8 out of 10, which means it's pretty high. And the reason it's severe is because it exposes sensitive information. So for organizations like ADB, which deals with financial data, and not because the value of financial data, but if you consider other sectors such as healthcare or scientific exploration, proprietary scientific exploration, then exposure of sensitive information is very detrimental for organizations. So you should not be, while implementing state reconciliation, if a tool is leaking sensitive information, then that means that there is a big problem there. And we wanted to understand how big of a problem this is, and if we can actually generate some actionable insights for practitioners so that these types of bugs are detected early, way early, because before they go into production and used by millions of users. So accordingly, the goal of this particular paper is to help in reliable state reconciliation and by categorizing state reconciliation defects. So as Adolfo is familiar, this was typically the norm, or still is the norm, in our advisory research group, where you have to have a goal, and the goal must be focused on a practical, actionable reason. So that is why you see the goal statements in both of these papers. And to accomplish this goal, we answered two research questions. One is, what are the categories? We wanted to see if the bugs that we are studying have some unique properties, and how unique are they? So for example, can we identify categories that have not been reported in prior research? If that is the case, then we can say that okay, these types of bugs have unique properties. And second, we wanted to use the information in RQ1 to do something more practical and actionable. So here's our methodology. It's a little busy, but to summarize, what we did was, as part of RQ1, we did a qualitative analysis technique called open coding to derive some categories. From the categories, we derived heuristics, which we use to answer the second research question. So you might be familiar with this logo, which is the OpenAI logo, and yes, we will see that we did actually apply large language model called ChatGPT, GPT 3.5 in specific, to answer research question. All right, so the dataset that we used was the Ansible version 2.14.0. In total, we found out 5,110 defects, which means that there are plenty. We actually used a lot of data, and there is similar to our previous study, these types of bugs are also free. So this particular picture summarizes our research questions. So in all, we identified multiple categories. So some of them are actually observed for other types of software systems, like type, then security, then conditional defects, idempotence. But we also identified some defect categories that are very unique to state reconciliation, such as state impurity. So this answer not only answers research question 1, but also showcases that the theme that we are studying, state reconciliation, is important, not only important, prevalent, and also relevant for practitioners, but also it also has some unique properties that we should be mindful of when we are trying to bring in quality assurance for infrastructure code. So to piggyback on what I was saying before related to the uniqueness, we actually we just didn't look into one or two papers and claim that we our study is unique. What we did was we actually did a scoping review of 21 publications that's published in IaC, JSS, Empirical Software Engineering, and TSC, and to make sure that we have a fair comparison with existing taxonomies with our taxonomy. And these are the categories that we identified as unique to state and council election, namely auxiliary, inventory, and state regulation. And here's the frequency. We see that majority of the defects belong to these two categories out of the 5,110, inventory and state inquiry. And there are some other types of bugs such as security, conditionals, types, and so on and so forth. All right, so the second research question I was alluding to that we actually use GPT 3.5 large language model. And our intuition was that, this study was conducted in the year of so we started, especially this part, we started in April of 2023 and then we submitted it in September 2023. That is when GPT 3.5 was the biggest thing, like the biggest hype, it's gonna change the world. And we jump into on top of that bandwagon and want to see ourselves if it can be used in our context. So the goal of research question 2 is to find new bugs. So far what we have seen are old bugs. Can we learn from these new old bugs to find new bugs? And that is wanted, and to do that, what we did was we applied the idea of prompt engineering. So if you are not familiar with large language models, you can consider that as a piece of software, and then you provide some prompts, which are natural language text, to that software, and in return, it gives you some answer. And based on that answer, you can identify yourself if it is effective to solve the computational task that you want to do. So you can look into the details of the of all of these steps in the paper, but what we did was we started with two types of prompt designs, and we did some syntactic evaluation, and then based on our syntactic evaluation, we used one particular style called paragraph style, and then we also did some preliminary analysis to see which one we should use. Currently ChatGPT has a lot of versions, but at that time we explored two, which is named GPT 3.5 and GPT 4.0. And from there we used GPT 3.5 to generate playbooks, which are Ansible scripts, to generate in order to find new crashes and then to find. So that was our methodology. So this is our experimental setup. So we found out that GPT 3.5 was slightly better for GPT 4.0. So we used GPT 3.5, the temperature was 1.0. And then we actually did not study the entire Ansible orchestrator. We focused on 4 components built in utils and common community. And because this required dynamic analysis, we actually had to set up an environment where we had a controller machine, and that controller was used to control or provision 3 Docker containers, one using an Ubuntu image, the second one using an OpenBSD image, and the third one using a Red Hat image. So you can consider these as 3 mini computers or small computers with their own operating systems, but which has a limited functionality compared to that of a full operating system like a Windows OS or a Mac OS. And then we generated the heuristics that was used using open coding, but the idea is that we're going to look into the defect reports themselves, extract text from there, and somehow do a grouping based on some established criteria like commonalities, and then come with this particular heuristic. So this thing was directly passed into the GPT 3.5 as So here is a very detailed verbal paragraph, and you can see that what a prompt looks like for a certain type of heuristic. All right, so now coming back to the results. So like I said, we actually used 2 styles and found out that the paragraph style was good. And then when we finish this execution, we notice that we are not able to generate playbooks like Ansible scripts that will eventually give us crashes. So our goal was to find out if we can generate a lot of crashes that will help us to identify new bugs. But as you can see, the number is pretty small in this particular case. So we generated 1,263 playbooks, from where we only found out 7 crashes. That gave us an idea that perhaps our approach is not going to help us fulfill our goal, which is new finding. And none of the 7 crashes validated bugs, so we had to actually change our strategy. The strategy was to generate even more playbooks, and the approach is on top of paragraph style prompting, we're also going to add heuristics. And all the heuristics that you saw in 2 slides before were actually applied to generate the prompts, and that helped us to not only generate more crashes with 211. So from 7 we would jump to 211. They also helped us to identify 9 new bugs. So here is the breakdown based on category. We found out that we were able to generate a lot of crashes for this particular category called type. And in all, we identified 9 new bugs, and as of today, 7 of them are confirmed by the Ansible community. So it showcases that our approach has shown relevance and impact based on open source contribution. And another breakdown is that we were able to identify most of the bugs that are type related and that are in history components built in the community. So it showcases that even though there is preliminary evidence on the effectiveness of using prompt engineering to find new bugs, but it is not. It's not like this is the final conclusion. We can still do better. And currently, we are exploring other techniques to see that if other techniques can outperform the heuristics-based LLM approach. So what does it mean from a practitioner standpoint and from a research standpoint? Number one is that like I was saying, that we actually have a lot of opportunity in finding new bugs, and it would be interesting if you can see that some other type of techniques are outperforming LLM-based approaches. So currently in software engineering research, the use of LLM is very prevalent. And if we can show that actually some existing techniques with some tweaks can outperform LLM-based techniques, then that can provide new insights and new directions for the community. And another issue with LLMs is that they are very resource intensive. So if you are using ChatGPT, OpenAI stuff, you have to buy them. And if you are using some open source LLM, like say Llama or say Phi2, then you actually have to go through all the challenges to download them and use them using a Hugging Face API and so on and so forth. And in the end, you see that they are not as effective. So our intuition is that there could be some other ideas outside of prompt engineering and LLM that can help us find out more bugs related to state reconciliation. So one area that we didn't do well was inventory, finding out bugs that are related to inventory. So there are a lot of opportunities in how we can do inventory hardening with fuzzing. Another interesting direction is now that we know that GPT 3.5 to some extent can generate syntactically and semantically correct Ansible scripts, can we extend that same idea for many tasks that are very common for infrastructure as code? In that case, if someone is very new, then they can actually use LLM as a tutor to guide them on how to write infrastructure code so that they can manage servers and computers. So just like an empirical study, we have conclusion validity because, for example, the use of heuristics that could be limiting. We start validity. Our defect categorization process is is subject to qualitative bias because we used two raters, and so we didn't use many more. And also the data set that we used is constantly changing. For example, if I want to replicate the same study in the year of 2024, we will see new bugs in the bug database that might influence the derived categories and the frequency. And finally, external validity, we only used the Ansible open source repository, so we actually do not know how generalizable it is to other types of Ansible orchestrators. But from our preliminary work, we did actually see that many of the defect categories that we have identified, like security and type and idempotent, also hold for chef and also for public. So the contributions of this paper are, so we identified a set of defect categories. It's a taxonomy. Taxonomies are always important to get interesting research going. The empirical evaluation of how frequently these types of defects occur. And also we have identified a technique which uses large language models to find out new bugs related to state reconciliation. All right, so I'm not sure if any of you would be attending FSC this year, but we actually have multiple talks related to infrastructure as code. So please consider attending. I'm not sure if they're going to release the recordings, but all the presentations will be available, and also the publications will be available through my website. So you can, if you are interested, you can download any of these papers at any one. All right, to summarize, I have discussed very briefly what infrastructure as code is, what strict reconciliation is. I've also discussed one of our preliminary experiments that we did, and then I discussed the results and the findings of this particular paper that I will be presenting at the FSC conference. But in general, I do believe that infrastructure as code is an underexplored area. We are not seeing a lot of research in this topic that actually has a lot of relevance for industry, and is a good way to do some research to make an impact, make a real world impact. So if you are, like I said, if you are interested in this kind of work, feel free to reach out to me. Just because you are a grad student or a master's student or an undergrad student doesn't mean that you cannot work on interesting research projects. So we have multiple undergraduate students who are actually helping us with these projects, and they also in turn become co-authors. And if you are interested in pursuing a PhD in US in the field of software engineering, please give us our consideration. And for any types of questions related to my research, please reach out to me via email or via Twitter. Thanks for your attention. Again, thanks Adolfo for hosting me. I will open up the floor for questions.
Great. So let me leave the slides here, but change the configuration of the microphone so that people can hear my voice and also everyone's voice here. So do you have a question? I have a question. Why do you think? I have a question from Marlon, but before I'm going to ask a question regarding does the Ansible community knows about these results?
So the Ansible community knows in the forms of bug reports. We actually have not shared the paper with them or shared any of our findings. But that's a good idea. So when we are submitting bug reports, we actually have to open issues on their main repository, and like I said, some of these bugs have been accepted. They know that we are finding bugs. We just didn't tell them that this was actually a part of it.
Okay, because I didn't know much about the Ansible before reading bits of your paper. I read that it's a company that was created in Durham, right? Durham close to Raleigh, and then Red Hat bought it.
Yeah.
And I remember having heard the name places, but I don't know much. But I don't know where does the Ansible community gather. So are they on Twitter? They have a Slack server, or if they have a Telegram group? But I know a bit from the Elixir community, which, and I remember that you wrote a paper,
Yeah.
maybe some students on the Elixir community, and when there was someone on Twitter criticizing that paper, so I didn't know about that paper. That paper wasn't, maybe this guy, he found it somehow, but the Elixir community didn't know much about that,
Right.
that paper.
Right. Yeah. So I know that there are some conferences like Ansible Fest, and then there's the Configuration Management Conference, or I think they call it a conference. I myself have not attended those, but maybe it's a good idea to reach out to those communities.
Yes, maybe one of your students can send it. Usually those conferences, they require just a small abstract, a title, an abstract, and a mini bio, and that's it. Of course, it doesn't mean you're going to be accepted, but usually they like, oh, there's research about this and stuff. The other question I have about LLM is that you did use the free version or the paid version? I was not sure. The ChatGPT.
Oh, it was the paid version.
The paid
So
version.
GPT 3.5. Back then it didn't cost as much as it costs.
Oh, okay. And some people say that, okay, you try something this week and then you try the same thing next week and the results are different. How do you deal with that? Because reproducibility is one of the key aspects of research. How do you do research with ChatGPT if it's not reproducible?
Right, that's a great question. I believe that I do not have a very good answer for that. The usual approach is that you apply repetition, and then you use repetition, and then your evaluation is based on some quantitative metrics. So, and then if your quantitative metrics most of the times are saying the same thing, that means that to some extent the results are reproducible. But again, just like any machine learning algorithm, LLMs, they are probabilistic in nature, and that means that you will get different results, slightly different results every time you query it. The way the code generation community, so who actually use LLMs to generate code for many different software engineering tasks, they have their own measurements where they derive them, they use the metrics in a manner which encompasses this variability that comes with LLMs.
Okay, so now let's see some questions from the audience here. I see that Marlon Pinheiro, he's in Portugal, is one of our students, said good morning. And
Good morning.
Victor Neis also said good morning. And Leticia Caminar. Leticia is a former student of us. I don't know if she's doing a PhD or if she's working, but I remember her. Gustavo Brito dos Santos, Marlon, and yes. So this question is from Marlon. Greetings, Professor Rahman. I'm Marlon Pinheiro, master student from PPGCA UTFPR. Okay, that's twice. When we talk about infrastructure as code, we are replacing the infrastructure setup manual to an automated way, if I understood it correctly. If you want, you can read also there. And then he asks, my question is, may we work with CI/CD or something similar in IaC as we do in our app codes, for example, in Microsoft TPS or Azure DevOps?
Yes, actually, there are some organizations who do put infrastructure code in a CI/CD pipeline. So that the tests are done automatically, and the stylistic checks, all of them are scanned automatically. So there is a way you can put infrastructure code in a CI/CD, in a CI pipeline especially, and then if everything passes, then you execute the code to set up your infrastructure.
Okay, so now it's Laudelino says, good morning. Laudelino is a professor at PPGCA. He's watching from home, and Marlon from Portugal. Gustavo, he's said he's on vacation. And Marlon, thanks, professor, great presentation. IaC is a subject that I'm not very familiar, although I did enjoy it. And you mentioned about using Docker to generate the IaC buildings to servers. This deploy is going to be relatively similar when you use Docker and containers, for example, microservices deploys.
To some extent, yes. So you would, in a typical microservice-based architecture, you would expect that one container is going to handle one microservice. But our experimental setup, to be clear, is very simplistic compared to that of how industry is doing, how industry is using containers to manage them. And that is where things like Kubernetes comes into play. So, for example, if you have 100 microservices and you want each microservice to be in one container or one Docker container, then again you will need some automated management system that will help you to keep control of these 100 containers, and that is where Kubernetes comes into play. But yeah, so short answer to your question is, it is similar, but it is not similar in the way it is currently done in industry.
Okay. Thank you very much. I see we have no further questions here. No. So I have one more personal question, and the other is more related to where you work now. Which the first one is back then when you were in Bangladesh. Why did you decide to follow? Was your undergraduate course computer science or computer engineering or?
Yeah. So my bachelor's was in computer science, such a degree program that is called computer science and engineering. And after I finished my bachelor's, I worked as a software developer or software engineer at a company. And at that time, one of my responsibilities was actually to manage configuration. So there was this a very interesting database developed in Microsoft Access, and I remember that I had to use heuristics to put a database and its configuration, and then go from one server to one machine and copy it manually and execute it manually. So when I was working there, I felt I always was curious to know what things work for software engineers and software project managers, and what things don't. I always had that curiosity. Luckily, at NC State, because it has great software engineering concentration there, I was able to explore those ideas related to software engineering more closely in supervision with development.
Yes, I remember you gave a talk there when I was there about DevOps, right? DevOps.
Yeah.
I believe you
Continuous deployment.
Continuous deployment.
Yeah.
Talk, which is related to DevOps. And you wrote a paper that was published on Azure, right?
Yeah, that was my first paper with Lori.
But how did you find Lori? Did you find while you were in Bangladesh or what?
No, so I finished after my undergraduate studies. I went to Yukon to do my master's. I didn't like it there, and there weren't any software engineering professors in the field of software engineering research. So I moved to NC State, and one of the reasons to move there was that in software engineering there were multiple professors. I actually, to be honest, it was Lori who found me and invited me to join her group and to come and see if I like the things, how things are done, the research that she does, and all that.
Great. And My question before was also, why did you choose your undergraduate course while you were in Bangladesh? I mean, did you have a computer as a kid, or did you know, oh, I want to be rich, I want to be a software developer? What was your motivation?
Well, it was more practical. The reason is that in Bangladesh, it is the norm is that you have to be, if you want to make a good living, you have to be an engineer or a doctor. You have to be somewhere. You have to pick up a profession that is in the field of science, technology, and so I eventually ended up. I wanted to be an engineer, not a doctor. I picked up computer science because it sounded interesting, but even though I didn't have any experience in working with computers, my first computer that I bought was in 2004 after I started as a student there in computer science.
So, and my last question is about Auburn University in Auburn, in Alabama. What's the region like? I know it's in the south of the United States, although many Brazilians don't know much the difference. For instance, when I went to North Carolina, I didn't know that North Carolina was part of the south, although it's north. And what's like to be in a university in the south, and what are the possibilities for people that want to do a PhD there?
Auburn University is located in Alabama. It is a state in the south. It's that the biggest difference is, of course, in weather. It's a lot hotter and more humid compared to some places like New York or New Jersey or Connecticut. There are some cultural differences as well with respect to, say, how people perceive religion and certain social norms. But from the standpoint of an international student, I do believe that Auburn University is actually a good university, and Auburn itself is a good college town because the living expense is not that high, the stipend is good, and the weather is not that extreme, so you do not have snowstorms during the winter. You do not have snowstorms every other week. Also, I also feel that Southerners also like food. So if you are a foodie, then get to explore, go to different barbecue shops, and then there are also options. And one benefit of Auburn is that it's very close to Atlanta, which is a large city, and you get to explore all types of cuisine and explore all types of cultures, different events, concerts, games. So I believe the Copa America, the stadium at Atlanta that hosted 2 or 3 games, and the 2026 World Cup will also have some games there.
Oh, yeah.
So that's an advantage of staying at Auburn. So you stay in a small town, which is not that expensive, and then you have access to amenities that you typically find in large cities like it.
That's great. So, okay, no. So, thank you very much. Thanks to everyone who is watching online. That's it.
All right. Thanks, everybody. Thanks for watching me.
Let me finish the transmission.